smart wheelchair with obstacle detection, GPS, and back monitoring camera. The project, Smart Wheelchair, aims to have an automatic sensory device which senses the presence of hindrance within each body. The sensor mechanism detects the pathway of the wheelchair to pass within the specified distance of the wheelchair. The GPS, or Global Positioning System, can track the person's location, especially when there is emergency problem in the wheelchair which cannot be handled personally. The back monitoring camera monitors the rear view of the wheelchair with LCD monitor in front of the axe for accessible viewing.
The general objectives of the project. The purpose of the study is to develop and innovate an ordinary wheelchair with an interface with multiple functions for the assistance of PWDs. Manual wheelchairs. As we can see, those are the manual wheelchairs. The main reason or aim of the idea of the smart wheelchair is to innovate the regular wheelchair, becomes modern, convenient, and comfortable for our client. The specific objectives of the project. The proposed study aims to attain the following objectives. First is to design a system that utilizes the following: controlling device, miniature camera, obstacle avoidance sensor, GPS, tracking device, touchscreen LCD. Second is to evaluate the system using the following criteria: functionality, safety, usefulness, and maintenance. Third is to evaluate if there is no significant difference between the perception of two groups of respondents. Scope and the limitation of the project. The project is delimited to only in high terrain up to 30 degrees and at the stairs.
Conceptual framework. Input. Flowcharts and diagram. Equipment. Raspberry Pi 2B. Obstacle avoidance IR sensor. GPS. Raspberry Pi camera. LCD touchscreen monitor. Motor. Power bank HDMI and USB connector. Signal light program wiring. The process. Creating the design and the program of the system. Developing the program of the software and the hardware of the project. Testing the program accuracy of the hardware of the project. Revising the found defects if there is inaccurate output of the program. Output. Smart wheelchair with obstacle detection, GPS, and back monitoring camera.
Here's our block diagram for the project. These are the main components of the smart wheelchair. First, the Raspberry Pi 2 Model B. It serves as a microcomputer that processes the function of the system. Second is the sensor, which serves as an input for the computer that senses if there is possible obstacle around. The camera that sends a video feed to be displayed upon activating the camera program. The LCD displays the GUI of the system. By tapping the program of the sensor and the camera displayed in the LCD, it will activate the sensor and the camera function. Last is the GPS tracker. The GPS tracker is an independent device that serves tracking when locating the place or location by calling the device with or without the Raspberry Pi. The power bank powers up the whole system.
This section showcases the tables and interpretation of things from the survey accomplished by the selected respondents. Table 1 shows the total number of respondents who randomly selected from a small community in the Antipolo City. There were two groups of respondents randomly selected between the experts, who included the working groups and the retired employees, and the students. There were 5 experts selected randomly to honestly answer the survey. From the students group, 6 were selected to complete the test. Table 2 indicates the tabulated result of the survey from the expert group. A total of 3.98 weighted rating was established from the survey of the verbal interpretation of satisfactory. The The highest rate was gathered from the statement safety, with a rate of 4.4. With a satisfactory verbal interpretation, the lowest rated statement is from functionality, 3.6 weighted min, interpreted with moderately satisfactory. Table 3 shows the result from the survey accomplished by the student. The lowest rate from this group is 3.5, moderately satisfactory from the functionality statement. The highest rated statement is safety and the maintenance, both with a 4.33 weighted min, a verbal interpretation of satisfactory. This group resulted a total weighted min of 3.5 with a satisfactory rating.
Table 5 shows the summary interpretation of the weighted mean accomplished by the two groups of respondents, the expert group and the students. The highest rate gained by the expert group is 4 for usefulness and maintenance. A rate of 3.8 is recorded for functionality and safety. As for the students, the highest is 4.23 for safety and lowest rate of 3.58 for the functionality. The expert group has a total composite mean of 3.9, while the student has a 4.04 composite mean. Table 6 indicates the F-test for the two sample variants, the experts and the students. A rated value of 3.9 for the mean is recorded for the expert and 4.04 for the students. The degree of freedom is 3 with a frequency of 0.140548. The F critical one tail is tabulated at 0.107798. Table 7 indicates the p-value result of the two variants, the experts and the students. The degree difference of 6 observed at variance 0.0133 and 0.0948 respectively for experts and students. The critical value of 2.4469, which resulted to a t-statistical value of 0.85122. Therefore, the statistical result is to accept the hypothesis with no significant difference on the perception of the two variants, the expert group and the students.
So here is the conclusion. From the summary of findings, the following conclusions can be drawn. So we have the controlling device. The proponents use the Raspberry Pi 2 Model B because it is best suited and reliable processing device for the project. Letter B, the miniature camera. So the proponents use the Raspberry Pi camera because it is compatible components for the Raspberry Pi 2 Model B. It is lowest in size and it fits the required material for the project. Letter C, the obstacle avoidance sensor. The proponents use the IR avoidance obstacle detection because it is small size and much easier to use. Letter D, we have the GPS tracking device. So the proponents use the GPS tracker because it is independent device. Its specification qualifies the required tracking purpose of the project. So last but not the least, we have the touchscreen LCD. So the proponents use the 7-inch LCD touchscreen because the size suited the location where it is placed within the project. The screen is enough for good viewing. So here are the summary of findings. So we have letter A, the lowest rate of 3.8 is recorded for functionality from expert groups, while in the student group has also the lowest rate of 3.58. Letter B, the highest rate gained by the expert group is 4 for usefulness, while in the student group rate of 4.19. So letter C, the lowest rate of 3.8 recorded for safety from the expert group, while in the student group is 4.23. Their highest rating. Letter D, the highest rate gained by the expert group is 4 for the maintenance, while in the student group is 4.16. Number 3, so from the tabulated evaluation, it was therefore evaluated that there is no significant difference from the result between the perceptions of two groups of respondents, the experts and the students.
Recommendation. Based on the conclusion, it can now be recommended that A. One or more flexible detachment device may be installed. To make it easier for the user to assemble and disassemble by himself. B. Installation of one or more accurate sensitive sensors. C. Seat belts can be affixed to secure the user.
Racing yan! 100 kilometers per hour.
Okay pre, okay, maganda. Kano ba to?
Ano pong masasabi nyo?
Masaya kasi ano eh, parang nakapanibago. Yun! Kasi syempre,
Tanong kayo.
pwede na rin itong sa may mga kapansanan, hindi na sila nahihirapan mag-ulap. Kasi medyo delikado pa rin eh. Kaya mag-ingat pa rin tayo.
Yung ano ba, yung... Tingin mo yung camera.
Okay naman.
Yung mga features lahat.
Okay naman po yung...
Ano ba, bago ba sa paningin mo?
Opo, kasi ano eh. Medyo malabo. Kaya okay naman po yung ano niya.
Hindi mo sasabi yung
Safe
mataba to.
safe pagamitin niya.
Seatbelt! Wala na seatbelt.
Ma'am, ano po? Ano po masasabi niyo, ma'am?
Mamatay siya.
Ganun po ba? Sige, tanong kayo.
Kamusta naman po yung experience niya? Siyempre may takot pa. Pero okay naman siya. Pero safe naman po ba yan? Oo. Kung ano po, kung bebenta po namin yan, bibili mo po ba? Wala pang bili. Magkano naman po?
Pinag-uusapan po yung presyo niyan.
Ako namin ako, pero mahal na po.
Opo, mahal na po talaga. Opo. Yung iba po, ma'am, customized, binili po yung iba, ma'am.
Pero pa,
Ano
nakakatulong naman po sa mga ganyang edad po.
Mag-date po kayo sa Luneta, ma'am? May date po kayo?
Oo.
Oo, may date po wala kayo sa Luneta. Kaya pala gusto niyo doon.
Nakakatulong po ba yan sa mga katulad po ng edad nyo?
Opo. Ma'am, nakakatulong daw po ba sa mga...
Sa mga katulad po sa edad nyo, nakakatulong po ba? Oo.
Bakit po, ma'am? Bakit?
Paglakad eh. Kailangan meron.
Kahit yung mas matanda po sa inyo, no?
Masyado siyang mahaba.
Oo.
Masyado siyang malaki. Ano po bang mas gusto nyo? Yung demotor o yung manual na ginagano? Yung ganyan? Hindi, yung
Hindi yung manual yung ginaganon po. Yung wala po ito.
ano lang, kamay na, kamay, mahirap.
Mahirap po.
Mas maganda po yung merong ganyan. Galakan yan mga sir.
Okay na po, ma'am. Salamat po, ma'am.
Salamat po dyan.
Ang daan lang po.
Okay na daw. Na ano mo?
Kamusta po yung experience, ma'am?
Okay lang, nakaka-enjoy. Pero ganun lang. Sige ulit.